Welcome back, everybody. So we're gonna finish up 6.1. 6.1, we recall, as we introduced the radian measure. So we're gonna finish that up. I'll call this part B, and then 6.2, we already talked about some of it, but not all of it. This is more on linear and angular motion. But it also has the unit, part of the unit circle in there. And recall we had, if we wanted to go from degrees to radians. Let's say we had 45 degrees. You multiply by, there's a relationship, it's either going to be pi over 180 or 180 over pi. And the 180 has degrees on it, and pi is in radians. Whichever you're trying to get rid of, you want that on the bottom. We're trying to get rid of degrees here, so I'm gonna put the 180 on the bottom, pi on top. And so 45 over 180, 180 is 45 times 4. And this reduces down to pi over 4. So we had a way to convert between degrees and radians. So you multiply by that. And if we wanted to go from radians to degrees. Let's say we started with 2 pi over 3. I want to get rid of pi because I know I don't have pi in degrees. So pi needs to be on bottom and the 180 is on top. If I do that, the pi's will cancel out. And 180 is 60 times 3. That's 180. We got a 3 on bottom, the 3 cancels. And we're left with 2 times 60, which would be 120 degrees. So this is stuff we did, it's been a week. I know it's been a while. But we did this week. And we talked about the unit circle. And I drew up. We did it by hand. We did a unit circle like this. I printed out enough copies for everyone to have like 3 copies if they wanted to practice. And we could pass them out at break time. If you want to practice memorizing radians and degrees, because it's going to be like half of your next test. No calculator on the first half, it's just doing this, filling in this sheet, this exact sheet. You know exactly what half of your next test is. It is filling this in correctly without a calculator. So I recommend making flashcards, putting the degrees on one side, the radian measure on the other, and just flipping through them until you can know what each one is, one way or the other, even if it takes you a couple seconds to think about it. Recall, we did have a strategy. You can watch the video on it, how we can go through and just go 1, 2, 3, 3, 2, 1. So there was a way to fill it in quickly, but you don't want to have to fill in the circle every time you want to do a radian to degree or degree to radian. Not if you're going through the engineering sequence. You want to be able to know that stuff. Kind of like the way you know 2 + 5 is 7. You don't grab a calculator to do some basic stuff. Okay? And that's why I make it part of the test. So if you want some blank copies at break time, come up and grab 3, and then at the end of at 5 o'clock, if there's any left over, you can come and grab as many as you want. So there were the more other parts in this section. We talked about arc length. Arc length was how far around the circle we had. We had a radius r and a degree theta. Arc length was the distance s. It's not a straight line, it's a curve. In fact, in Calc 3, right now, they're working on doing in a vectorized form, comparing the arc length, which is the distance around the curve. Versus connecting the 2 points directly and finding out what the distance is, which is called the displacement. They're doing something like that right now. This will be used often. The arc length idea. A lot of calculus has arc length in it. And the formula for it was S equals R times theta. Theta has to be in radians. So this is your whole, it's been, oh shit, it's been like a week and a half, right? Yeah, it's been a while. I will have your test on Thursday. I had every single problem but the last one graded on Saturday. And I didn't get it done, and Sunday I was busy doing stuff, and same with Monday, so they'll be done soon. Work shit for most of it, but Sunday was a game day with friends. You'll have it, this is my weekend too. Y'all don't just get the break, goddammit. Alright, you guys ready to do some problems that are related to this shit? Alright. So we're gonna say a circle has a radius. I should say circle, but it didn't look very good. Radius. Oh, David, pick a number for me. Have a decimal in it.
5.6.
5.6. I wrote up twice. As a radius of 5.6, what's your preferred unit?
Centimeters.
Centimeter. Get out. Americans don't pick fucking the metric system. As a radius of 5.6 centimeters. Let's find the length of the arc. If there is a central angle of. Let's do a few of them. On A. Spencer, pick an angle for me.
Sorry.
Just pick a random angle for you. You decide, degree or radian. 234 degrees, because he's a sicko like that. Couldn't pick a nice number. I like it. That's good. To make it like who else wants to pick a number? Patrick, you want a number?
Be 187.
187. And since who wants to pick a radian? Abby, pick a radian amount for me. Just pick a fraction and I'll add pi to it.
-230.
And then we'll do negative. Okay. Negative 2/3 pi. Let's do it. So. S equals R theta. So we're looking for the arc length. If theta is not in radians, you want to make it part of your conversion process. So our radius is 5.6 centimeters. That's going to be on all of them. I'm going to use the same circle for all of them. And on this one, we chose 234 degrees. And we're going to have to send it through the conversion mill of pi over 1/8. .6 times 234 times pi. Divided by 180. And let's do. I'm gonna do 2 decimal places. Just because I want to. 22.87, what? What are the units? Centimeters. The degrees went away, these were radians, but radians don't have any units, the only units we had left were centimeters. Listen,
Is there a calculator and?
actually, in this one, as long as we're not using the sine, cosine, or tangent function, you can use either. If you, as long as you're not, well, or an inverse trig function. If you're not using a trig function on your calculator or an inverse trig function, doesn't matter if you're using degrees or radians. Alright, what should I do for B? Someone tell me,
Same process,
same process, which means doing what?
converting to radians, because it's not radians.
Okay. So tell me what you write down.
187 degrees times pi over 180 again.
Yep. So actually, this is fun since. If you already have the old one in it, the only thing that's different is the 234 and 187. I'm actually gonna shortcut it, I'll do it both ways. I'm gonna do divided by 234 to wipe out the 234 previously and multiply by 187. And I'm pretty sure we're gonna get to 2 decimal places 18.28. But I didn't do it out the long way, so I'm gonna do it out the long way as well. 5.6 times 187 times pi divided by 180. And still 18.28 centimeters. Okay, what about -2 pi over 3?
Multiply. There's nothing starting with these.
This is already in radians, I don't need to change it, that's correct. So 5 pi over or not 5 pi, 5.6. Times. -2. Divided by 3 times pi. And I'm getting. -11.73. Anyone else get this on their calculator? Are you guys good with that answer?
Wondering why.
I do. I didn't. So if you do, that's a good, oh, this is a fucking great thing, because Gerard has asked this. On the weekends, I did in my calculator 5.6 times -2. Divided by 3 times pi. This is the correct thing to do, if pi is in the denominator. If pi is on bottom. I would have had to do 5.6 times, the only reason I'm putting a negative parentheses is because to make it clear the negative's there. If I'm dividing by pi, I would have to put this in parentheses. Or say divided by 3 divided by pi. So if you have more than one thing on bottom that's being divided, you either have to put in parentheses. Or you just say divided by both. Because the calculator is not recognizing. From this, order of operations says division by 3 happens before multiplication by pi. And that means they're on separate lines. Separate action. So, in the calculator, correct what I did. Now. If it makes you happy, I could easily have just said times pi divided by 3. And got the same thing.
Can we also input the answer into simplified radical form? Like for example, like I don't know if that's the correct name, but
What do you
like
mean radical?
for example, negative, like the fraction, right? Like, cause I get this I get like the fraction and then I get a negative, then 56/15 and then pi.
Okay, we can, but is that gonna be useful to you in terms of arc length?
No,
Okay.
yeah, because sometimes it throw it like that, but I can convert it to the,
I think your calculator is like your reps. Right, calculator. Computation. He made, maybe I almost just threw his shit on the ground. He made me learn how to use this shit this weekend.
yeah, because I did the same way he did it right there, and then look at that.
So what did we do? We went mode, no, that's not it. Wait, how did we do this? It was.
For the mode,
Was it mode?
for the man.
There we go. Does yours have a screen like this if you hit mode?
No, it's a Casio, but like if I hit a mode, like it's just these three.
Okay, I'll have to look at your calculator separate. If your guys' calculator like this is this, and it's giving you a pi answer and you're like, I need a decimal. Hit mode, come down here. And hit enter for classic. It'll do decimals. Math print. Makes it show the pi. Okay, if your calculator might have something similar to this, but not show it on the screen.
Yeah,
It might show it separately, but there will be, this is classic versus math print. Math print uses pi, it uses the fraction, because the decimal, even though it has got a lot of digits. The screen can only show so many digits, which means it's rounding, which means it's wrong. Wrong as in not exact. And depending on how much precision you need. That matters. If you're working on something that costs hundreds of millions of dollars, you want exact. You don't wanna hope that 9 decimal places is good enough. Cause it might be that you needed the 10th fucking decimal place and then you didn't do it and you just blew that shit up. Okay? So there's a difference there, exact versus approximate. I don't like the answer to number C. What? It's a distance, right? Why would we have a negative distance? Doesn't make any sense. So, let's just make it positive. It's distance. The negative 2 pi over 2 is actually a great choice. Alright, you guys ready for another one? Are we having fun yet? Yeah, more Mr. Jones. I love this shit. I was starting to twitch this weekend because we didn't have class on Thursday. I needed my drink dose. Anyone need it up longer? I hope not, because I went on some big old things like the calculator for a while. Alright, so we got a drum. Like a barrel kind of thing, barrel, a drum. This is a drum. And a rope is being wrapped around it, there's a rope on it. A rope is wound around a drum. With the radius. I don't know, let's go with 0.612 meters. How much rope has been wound? If it's the drum is rotated. Uh. 146.1 degrees. You know what, a needle and thread is a much better example of this, because like it is literally wrapped, that's how fucking thread comes, it is wrapped around a little thread drum. This thing is not great, I changed the numbers. So that we had different numbers, so we have a similar long, but this is the picture they used. And I don't know about you, but this rope looks super fucking rich, it looks more like a chain. I'm like, that's not a fucking rope. So it might be easier if I look at the circle like dead on. Let's say the rope is affixed here. End of rope. And 146.1 degrees is that less than or more than half a circle? Less than, why?
80's half circle.
180 is a half a circle, so I know it's not wrapped completely around, or not even halfway around. Halfway would be there, so I'm gonna say the rope is wrapped like that much. We're gonna say that's 146.1 degrees. And the rope goes off like that. And the other piece of information we're given is the radius is 0.612 meters. How do I find the amount of rope so far that's on the drum? We do arc length. How's that come in? What do I do with this?
Convert it to decimal radians.
We're gonna have to convert it to radians, right? We're doing R theta. We got 0.612 meters. We've got 146.1 degrees. And am I doing pi over 180 or 180 over pi? Pi over 180. And plug and chug. I'm getting 1.56. Someone else tell me if you got the same thing. Cause I am prone to fuck up the calculator with my big old fat fingers. What are the units here? Meters. Ready for more? This problem is kind of like a 10-speed bike. A 10-speed bike problem here. What we're doing here is I've got two gears that are interlocked. So gears tend to be round and have like teeth on them. That's a gear. And this is interlocked on one that's a much bigger gear. And I don't wanna draw all the fucking teeth, so I'm gonna just leave it at that. And the smaller gear. rotates. Causing the bigger gear to rotate. Ten-speed bikes tend to go the other way. The big gear rotates and it turns the little gear. You pedal out and the pedals hit the big gear. And it turns the little gear which is attached to the tire. Let's say this one is. 2.6 inches, maybe right over here. Smaller is 2.6 inches. And larger is 6.5 inches. If the smaller gear rotates 120 degrees, how many degrees does the larger one rotate? So that makes this 6.5. So if the smaller gear is moving, what part of it is affecting the bigger gear?
The S, right?
The S, right? I already said the smaller gear is pushing the bigger gear. So but it's not like the angle, it's not like the radius, it's how much the outer surface is turned, because that's the only thing that's touching the other one. So if I say this is like S1 equals R1 theta 1. And this is like S2 equals R2 theta 2. Because they're different radiuses. S1 how should that relate to S2?
It should be smaller.
Same.
I hear smaller and I hear the same. Anyone think it's bigger? So let's think about if the two things are touching, one's rotating and pushing the other. Should it push it at the same rate or less than or more than?
Oh,
Yes.
yes.
It's actually pushing at the same rate. Like if you have two things moving, they gotta move together. Now the radius is bigger, which is gonna make it so like the angle is a different angle. But the actual amount of arc length that's being moved is the same. Like if I had if I had paint on this, if this put out paint. As this one turned, it would put paint on the same amount of arc length as the other one, as much as it spun. So S1 should equal S2. Which means I can set those two equations equal to each other. I can say R1 theta 1 equals R2 theta 2. And we have some information for these, R1 was 2.6 inches. Theta 1 was 120 degrees. I could do the pi over 180. But I have to do the pi over 180 on the other side too, and now I convert it to radians. And I don't want radians, I want degrees, so I'm actually gonna leave this in degrees here. But maybe I'll show the pi over 180. I'm gonna show the pi over 180 on both sides. R2 had a radius of 6.5 inches. We don't know what theta 2 is. But it's in degrees and it would be pi over 180 degrees. Now I want theta 2 in degrees. Cause it says how many degrees. So I really don't think I can get rid of the pi over 180 on both sides. If I divide both sides by pi over 180, they cancel out. So if I divide both sides by 6.5 inches. I'm gonna get theta 2 equals 2.6 times 120 divided by 6.5. And that gives me 48. What are the units on the 48? Degrees. Notice on, if we look at it over here, the inches cancel out. And the only unit we have left is degrees. So the bigger gear turns less. If you do this the other way, like on a 10-speed bike, you're turning your pedaling on and it's rotating. Your pedals are attached to the big gear, and then a chain link attaches it to a small gear, which is attached to the tire. 10-speed bike goes the other way. Or, what, 3-speed mountain bike? Don't they have a 3-speed bike? I don't know. So there's a big gear and a little gear, and this is the one with the fucking pedals on it. And there is a chain that connects it. And this is on the wheel, back wheel. Since they're connected by the chain, the arc length stays the same of how much it's turned. So turning, notice how when we went from a smaller circle to a bigger circle up here, we lost a lot of angles. Our 120 went drop down to 48. When you go the other way and you turn the bigger circle to drive the smaller circle, it goes up. In fact, let's see how it would go up. Let's say we have the same problem. Let's say R1 is still 2.6. R2 is still 6.5. We don't know what theta 1 is, but theta 2 will do 120 degrees. We're gonna use the same degrees. So we're pedaling the bigger pedal. This doesn't look good. Pedals should be on the opposite sides of the wheel. That looks stupid. One's up, one's down. They're not at a fucking 45 or 90 degree angle. That's just bad drawing, Dave. So we've got R1 theta 1 equals R2 theta 2. And we plug in what we have. 2.6 inches. I don't know what theta 1 is. R2 was 6.5 inches. And theta 2 was 120 degrees. Which is 1/3 of a full pedal, full circle around. So we didn't even pedal all the way around once. We divide both sides by 2.6 inches. Again, the inches cancel out. I'm getting 300 degrees. Way less than half of the circle. On the big one, rotated the little circle, almost a full circle. And the little circle's attached to the wheel, and so that as much as the gear turns, the wheel turns. So that's how, like, a 10-speed bike has different rings here. And you can drop down to have a different gear ratio. Which affects the amount of work you put in versus how much this rotates. Yeah,
So what would be the gear ratio? Right.
yeah, if we look at it. Like, let's say we just did one full circle. If I did one full circle, I'd have 6.5 times 360 over 2.6. And we'll see what the end result is. Well, that's not the best way of showing it. This is. What the hell? I totally typed the wrong thing. 660 divided by 26. This is showing 900 degrees.
2.5 times.
It ends up being 2.5 times. It's a little bit easier. Instead of saying 360 degrees, saying one circle. 2.6, and then you'll see this is 2.5 circles. So the relationship or the ratio we had here was 2.5 to 1 or 2.5 to 1 or the equivalent would be 5 to 2. That's why doing on the biggest speed on 10, has anyone ridden a 10-speed bike? I know like bikes aren't as popular anymore. God damn, one hand fucking goes up. Really? The rest of you, not even the other adults? Like adult, wow. Never, not even as a kid? I'm not talking about recent shit, alright. So you pedal, it's a fucking, if you're in 10th gear, you're pedaling a lot to drive, one big pedal rotates this a lot. Which means you're having to rotate that wheel that's hitting the ground a lot to push the bike, it's harder to do. When you have in a lower gear, it's a 1 to, like, it might get down to 1 to 1. Ratio where it's just you're doing the same amount, so like. To rotate one full lap takes less work to do than rotating a lot more laps. So it gets easier the lower gear you are on a bike. Holy shit, like 2 hands. I didn't think I was that fucking old. I know it gets hot with Valley, so like riding a bike kind of sucks, but I thought more people did it.
So when you go like uphill, is that where you go into the big gear?
The uphill is already harder on its own,
I'm trying to remember which way.
so most people don't stack hardness with hardness. It's harder to pedal in 10th gear and it's harder to go uphill, so most people drop down to a lower gear because it's easier on the legs. You don't go as far, you have to pedal more to get the same distance. But you're not pedaling as, each pedal is, each lap around the wheel isn't as hard. So you tend to drop down gears when you're going uphill on a bike. Alright, so that was arc length, there's a little bit more in this section. And what else could we talk about? Where we have something rotating a certain amount. Arc theta. If I'm not talking about arc length and I'm not talking about R and I'm not talking about theta, what else could I talk about this picture?
Area.
Area. So area of a sector. The area of a sector is 1/2 R squared theta. This, I'll be honest, is a pain in the ass to memorize. I oftentimes, if I need it and don't have it in front of me and don't wanna go look it up, I derive it. So I'm gonna show you like how you can get this formula. So I'm gonna look at like area of sector. over arc length. A sector. Versus, I'm gonna compare that, it should have the same relationship or proportion as area of a full circle. Compared to the arc length of a full circle. Circle. So the area of a sector, we don't know what it is, if I'm trying to remember it. Arc length is S equals R theta, I'm gonna put R theta here. Area of a circle, I have that memorized. If you don't get it memorized, 'cause if you're going down any of the calculus stuff. Circles come up a lot, area of a circle is pi r squared. And the arc length of a circle is known as another name, what is it? It's the circumference, which is 2 pi r. So I'll just multiply both sides by r theta. I wanted A, I'm gonna get A. I end up having pi r cubed theta on top and 2 pi r. 2 pi r on bottom. Pi's cancel out. R cubed is r times r times r, and r on the bottom is r. If I cancel them out, I'm left with r squared. And I got a 2 on bottom, I have r squared theta over 2, which is a much less friendly way of writing 1/2 r squared theta. And it comes with like, just if you have these memorized and you remember that S equals R theta, you can make a proportion to come up with this. Again, since S is in radians. The A has a theta in it. The theta has to be radians also for A. Since it's based on arc length. So. You've got a sprinkler in the front yard. Not one of the ones that goes like this, back and forth like this, it's one that goes. And it fucking rotates really far back, and it's designed. Yellows.
Sorry. On the 1/2 r squared theta. Right, it was r squared theta.
Yeah, that's the same, they are the same. To me, I don't know about you guys. This one makes me stop and have to go, huh? And I don't know why, it just does, where this one, I just go, okay, whatever this is, take a half of it. Which isn't any different than saying, do it and divide it by 2. But like, you'll find like, especially in calculus. Having it separated, sometimes you have some weird shit on top and like, you're like, huh? What's going on? And then, but if you put the fraction out front. You'll be fine. It's much easier. So a sprinkler, like, let's say, I don't know, it's. Fucking much larger square. Fuck it, we'll do your front yard. This is your yard. Sprinkler in the corner and it fucking shoots out a radius. Let's say it covers that much. I don't know, how big's my yard? Let's go with its. Let's say that's about 20 feet. And the sprinkler is right here in this corner. And it's going. I don't know if you ever looked at a sprinkler, some of them spray out in all directions at once. Some of them do this rotating thing where they shoot a little pulse And the thing keeps ticking as it goes over until it gets to the end of its rotation. And it goes, and it goes all the way back to the beginning. Which seems like. There's gotta be some way to make it go back, I don't know how it fucking goes back. So there's some magic in the mechanical engineering shit that's going on in that sprinkler versus this one. But effectively, it's doing the same thing. How much? Yard is watered. By that single sprinkler. I feel like I should have made the box green and the fucking circle blue. Right, cause it's grass and it's water, but your teacher's is fucking scrub. Little raindrop, water drops. So we're using A equals 1/2 R squared theta. What is R and theta here? R is the 20 feet. What's theta? It's 90 degrees. Does anyone remember what that is in radians?
pi/2.
It's pi over 2. If you can remember in radians, we don't need to do that fucking lame ass formula. We can make this shorter. So we're gonna do 1/2. 20 feet squared. And if you get 90, you're gonna have to do the times pi over 180. But if you remember it was pi over 2, you can jump straight to that. Twenty squared is 400. And there's a pi. And on bottom, we have 2 times 2 is 4. And the units are feet squared. Which means the area is 100 pi square units. Square feet. But 100 pi isn't all that fucking helpful. But knowing it's 100 pi, pi is 3.14 times 100, this is approximately 314 square feet. There's some more decimals there, but. Is that not cool shit? One hundred times 5. I just know what pi is, so I skipped the calculator part. Use the number pi. Every calculator, unless you have. A total like non-scientific, like my mom's fucking calculator, it's got buttons that are like the size of fucking Oklahoma. And it only has the numbers and plus, minus, times, equals and that, like. Every calculator will have pi on it somewhere, any scientific calculator has pi, so just button. Use it and it don't round until the end. In fact, I noticed that on the test. It came up. Some of you haven't taken it, but you already know there's the problem it's building on with the 2 heights. Some people did the heights, wrote the exact value, then took the approximate value of each. rounded early, rounded on each of them, then added them together, and the overall effect of rounding twice made the answer wrong. It changed the number by like a full foot. Or meter or whatever the fuck I think it was feet. So having both rounded ended up changing it. Just two of them, rather than just rounding once, just rounding twice, fucked it up. It's kind of crazy. Alright, let's take a 10-minute break. Then we'll hit 6.2, which is on angular motion. If you'd like a couple of these unit circles to practice on, come up and grab 3 for now. Some people aren't gonna want one. So we have leftovers later on, you guys can have it when you want. Maybe I'll count them. Yeah, I did not pre-sort these. Let me hit pause on the video. Lecture. So lecture here, we are hitting 6.2 now. Is on unit circle and circular functions. So what is a unit circle? When you see the word unit in math, unit means length of one. How that corresponds to a circle, the unit circle has a radius of 1. Whatever the unit. And I really hate that they do this, because I don't think that I've ever used it, but who knows? I'm not an engineer, maybe you'll probably use this shit. So if S equals R theta. And R equals 1. That means S equals theta. The radian measure equals the arc length. Now, that's neat in my head, that's neat. But that's more of like a fucking Jeopardy question to me. What they do is we were using x equals r cosine theta. And we had y equals r sine theta. Which of course, recall stem from cosine theta equaling x over r. Sine theta equaling y over r from our picture. But if r equals 1 and if r equals 1 and theta equals s. They started writing, they're like, for this section, we're gonna say cosine of s. And y equals sine of s. Now, I don't think this is fucking helpful. And I'm not gonna use s again in the angle. Why? It's just confusing. If they're the same, why not just keep using theta? The only time it's of any help is if you actually know the arc length and not the angle. But like, that's something you would have to actually measure out, and it's a lot harder to measure that arc length around than it is measuring the angle, so I don't see where you would ever use s over theta. So I won't use s inside, but you can. The other thing about the unit circle, since we had x squared plus y squared equals r squared for a circle. That's the equation of a circle in algebra. R equals 1, the unit circle has x squared plus y squared equals 1. Again, as long as you know what unit means, you don't need to memorize a special formula for it. You just plug 1 into your radius for your circle equation and you're good. is neat though, that's kind of neat. I kind of like that, I think that's kind of neat. Because one's measuring like the distance around the circle, and one's measuring the angle that you did to do it. And with the right radius, they're the same. That seems like nice nifty coincidence. Let's go back, what really pops up in this chapter though is. Speed, linear and angular speed. Draw that fucking 10-speed bike again. And maybe this little one is attached to the big wheel. It's got spokes on it, we're pushing the big wheel, that is not a well-centered circle, but. You know, this is an art class, deal with it. So like linear speed. Just so you can get a difference in your head. Linear speed is how far the bike goes. Which is effectively like. Speed in for something like this, we're gonna use the word velocity. We tend to use that, we use V for it. It is the arc length over time. Like. When we talk about going 65 mph. That is 65 miles per hour. And mile per basically means division. That means that, or effectively, these are all the same. Or 65 miles over 1 hour. So it's a distance. Speed is a distance over time. And when we relate it to a circle. The arc length is gonna be our linear speed. And for angular speed. Oh, the page all rotated. Angular speed also has a distance over time. What we use for that. We're more worried about the angle. How much has the angle changed over time? Change in angle over time. Well, we use theta for angle and we use t for time. And the letter we use to represent this is a fancy W. Don't do a W like that. It is very much, it's got a curl to it. This is the Greek letter omega. Well, lowercase omega. It's a Greek letter. I think it's lowercase. It almost looks like a butt. Like a artistic butt. So we're looking at a circle. Let's see, I'm gonna do something like that. And then I'll fill in with red here. The rest of the circle. And then I'll do green for my angle, because that's the colors I use for the other thing. There's definitely a relationship between these. It is worth mentioning. Again, theta has to be in radians. For any of the other follow-up equations to work. So this can be written in degrees. But it doesn't interact with other equations the same. And if you do degrees, you better note it's in degrees. You gotta have the right units. I told you guys about the fucking NASA and the International European Space, like fucking up, like yeah. Same idea. Yeah, you wanna have fucking, it's assumed by everyone that knows angular speed that this is in radians. And if you use degrees and don't say it's in degrees, this is completely unusable by anybody else. In fact, if they have any idea what you're talking about, they're gonna be, what the fuck? That's not possible. So how can we relate these two? What? Arc theta over T? Subbing in arc length? I like it, let's do that. It's there. And you may not recognize it because the R is on top here. This is the same thing as R times theta over T. B equals R omega. We're ready to look at some example problems with this. These are the big three to remember. That connects them. If you recognize the connection, you only need to remember two of them. Let's say we have a circle. Radius, this is a, I don't know, maybe it's a pi. 16 inches is a big pi, right? That's not a radius, that's the diameter on the fucking pi. Oh well, this isn't a pi or a pizza. 16-inch radius on a pi, that's a fucking big pi. Right?
Yeah.
Biggest fucking slice of fucking pie, right? Cause that means it's like 32 inches wide, which is almost 3 feet wide. That's almost a fucking yardstick sized pizza or pie. That's fucking big. So we're just gonna go with 16-inch radius not being a pie. It's a big tire. And so this is 16 inches. And let's say this is point P on the edge. And now let's say this rotates. At. Pi over 6 radians per second. Find the angle generated by P. After. What should we do? Alright, let's do it after 1 minute. How many times is this going on? Let's upgrade this. So which equation do I need here? Well, I'm gonna ask some more follow-up questions for this, but this first question,
It equals.
why omega equals theta over t? I agree. Why?
Because the first thing we have to find is the main particle.
Yeah, what is this pi over 6? The pi over 6. Radians per second, that looks like a theta over a time, which means this is omega. And they gave us time was 1 minute. So I've got pi over 6 radians per second equals theta over 1 minute. And if I want to get theta by itself, I multiply both sides by 1 minute. We're in clear fractions because we say about fractions. So theta equals pi over 6 times 1. And the radians show radians over seconds and then times minutes. That's not good, right? The time isn't canceled, enough time isn't in the right units. So I need to adjust this. What can I do about adjusting this?
We can convert seconds to minutes.
We can convert seconds to minutes. There is 60 seconds in 1 minute. How did I choose to put that where it is? I looked at where my units were before, and I want my units to cancel out, so they're gonna be opposite sides of the fraction. And with them being on opposite sides of the fraction, the minutes will cancel and the seconds will cancel. Cause we had to kind of like choose. We could have done 1 minute over 60 seconds. Or 60 seconds over 1 minute. Picking the right one, they both are the same relationship. But this one will cancel out the units we need it to. Cancels units. So I have theta equals pi over 6 times 60, and all I've got is radians left. 60 is 6 times 10. And I get 10 pi radians. Or theta equals 10 pi. How many circles is that? Or how many loops?
So
How'd you get that?
2 pi's.
1 loop equals 2 pi. So I could say that 1 loop over 2 pi equals 1. If I divide both sides by 2 pi. And so you just multiply that. 10 pi times 1 loop over 2 pi. we get 5 loops. This is how you can do any of them. Start with the relationship, 1 minute equals 60 seconds. Like it doesn't need to start as a fraction. Do the equality that you know, the equalness that you know, 1 minute equals 60 seconds. Then just choose to divide both sides by the one of the sides. Picking it, like here, this one, I divided both sides by 60 seconds, both of these equal 1. I'm not changing anything because they're the same amount of time. That's the big thing, if you're gonna multiply by a number, it needs to be equal 1 to not change anything. So that allows us to convert between units. That's 5 loops, alright. Let that sink in for a second. Then let's go with how far did the point P travel? Any ideas? What I can do here? So P is on the edge of the circle and the circle's rotating. What is the movement of P describing? Circumference, but like in a smaller sense, if it wasn't a full circle, it's related to the arc. So we're really looking at arc length travel. And that is our good old S equals arc theta. So maybe I should have added that one in up here. That's old news though, that is important in doing this stuff. S equals arc theta. Do we have what we need to find arc length there? And if so, what is it? How do I calculate it?
IR, right, would give you 1 full loop,
You can do 1 full loop, yeah,
then times that by 5.
okay. We could do 2 pi r, which is 16 inches. And we did 5 loops. Now this is David saying, fuck you and your S equals R theta bullshit. The other way of doing it is we had 16 inches. And theta was 10 pi. Well, you'll see 2 pi times 5 give us the 10 pi, and this is the same result. So, if I multiply this, I have 160 pi inches. And this is one of those where you're like, that's fucking meaningless. Like I was able to look at 10 pi and figure out how many loops it went around. But if you told me like something traveled 160 pi inches, I'm gonna tell you fuck off, that's not helpful. Right, so that's where we wanna like convert to a decimal. And we'll just round to a couple decimal places. 502.65. Let's do that. 502.65 inches. Alright, finally. Let's find the linear speed. P in inches per second. So what equation do I need to use for that? What? A little louder?
Velocity.
Velocity, which one? Let's do the S/2, that seems like the easiest one to use. Cause we already calculated S, right? I'm gonna use the 160 pi for now. I'm gonna do the rounding after I divide by time. How much time did it take to get that 160 pi? It took 1 minute or 60 seconds, right? Alright, now we can go through and figure this out in radians per second, or inches per second. 160 times pi divided by 60 equals 8.38 inches per second. What if you had wanted to use V equals R omega? That was 16 inches. What was omega? Omega was pi over 6 radians per second. Sixteen times pi divided by 6. Same thing. So depending on which one you have the information for, or the first one you think of on that one. If you have all the pieces of information, you're good to go. Now, if we hadn't calculated arc length yet, like if we just went to. How much is the width of the outside of the wheel turning? If we didn't do S yet, that wouldn't be helpful, but we started with R and omega. So depending on what order the questions are asked, you may not have all the information. Ready for one more? Back on word problem day, right? Basically, you let it spin all day, goddamn day. You're like, I don't like word problems. Who doesn't like word problems? It's okay to admit it. Most people don't. Why? Anyone know why you don't like word problems? Let's figure out what to do, or like really not necessarily figuring out what to do, but like kind of how to turn it into math. It's really translating
It's better
English
to
into
just
math.
have the data and then just do the math.
Right. If you had a bunch of data, this might be easier to do, but usually it's a fucking paragraph. And you kind of have to like pull out of the paragraph. It's really translating English to math. And that's the biggest challenge. It's not the math. It's the fucking English. So hate on the English, not the math. Yeah. See how I did that? Alright, that should have given people time to finish writing that one. Then we need this up longer? Okay. Finding angular speed of a pulley. Let's find the angular speed of a pulley. And the linear speed of the belt or rope. call it a belt when it's on an engine, if it's something like basically if a machine's doing it, it's called the belt. And if a person's doing it, it's generally a rope. But a pulley is like literally having something like this. You hoist up a weight by pulling on a rope. Because, why did we come up with this? Lifting is fucking hard work. You actually are fighting the weight the whole way, and it's pure arm strength. By pulling over a rope, I gotta put in the same amount of fucking work. But now gravity, my body weight, I can use with me. I can lean back on that motherfucker. But really, that's the only help of a pulley. Plus, like, I can only lift so high with my arms. But if I had a pulley way up in the air, I can hoist that motherfucker up pretty high. So, we've got a pulley. The pulley has a radius of 5 inches. And it is rotating at 120 revolutions per minute. And we're gonna do the very first thing, find the angle that we said, find the angular speed and the linear speed. So angular speed is omega, right? That's theta over time. And we started with 120 revolutions per 1 minute. So we make a fraction like that. And I don't want revolutions per minute, I want to end up with radians per second. So I need to get rid of revolutions and I need to get rid of minutes, right? What's the easiest one to figure out right away? The time, most people are comfortable with the time, right? So we got that 1 minute to 60 seconds. We just gotta choose which one we wanna do. 1 minute on top, 60 seconds on bottom, or 60 seconds on top, 1 minute on bottom. What do I wanna choose?
1 minute on top, 60 seconds. Bottom.
Why?
I'm gonna divide the 120, and then also you have opposite or like terms. And a numerator and a denominator.
Yeah, we've got the same term, the minutes are on opposite sides, numerator and denominator. Look at you using the math jargon. So our minutes go away, now we're down to revolutions per second. Viva la revolution. It's not that revolution. Interesting how those two words, one word has two drastically different meanings. How do I go from revolutions to radians? What is a revolution? It's one full circle around, one full revolution is one circle around. And that's
2 pi.
2 pi, right? So. 1 revolution equals 2 pi. Which means I can use 1 revolution over 2 pi. Or 2 pi over 1 revolution. Both of those are gonna equal 1. Which one do I wanna use?
Revolution at the bottom, because you want it to cancel out.
We want the revolution on the bottom, so it cancels out, right? So I'll pick the one with the revolution on bottom. And now revolutions cancel out, and pi is in radians. And this shit's good to go. I have. Look at that, there's a 60 on bottom. So we've got 120 times 2 pi divided by 60. If I ignore the units, because we already got the units where we wanted them. 120 is what times 60? It's 2 times 60, right? And think of it in terms of time. And our 60s cancel out, and we get 4 pi. 4 pi radians per second. That's pretty fucking quick, that's 2 full circles per second. But we already knew that, it was 120 revolutions per minute. Now let's find the linear speed in inches per second. So linear speed is what letter? V. So we're finding V. So we have 2 options here. We have V equals S over T or V equals R omega. Which one should we work with and why? We have the radius and we have omega, right? We just calculated omega. We know the time, but we don't have S, so if we used S over T, we'd have to calculate S first. So, fuck that one. We're gonna use this one. We have all the information for this one. Work smarter, not harder. R was 5 inches. And omega was 4 pi radians per second. So it looks like we got 20 pi inches per second. And that's no bueno. Cause that's not meaningful. I don't know how far 20 pi inches is. So like if it makes sense and the unit is, leave the pi in there. But if the pi doesn't make sense, like it doesn't help you determine something. Put in a calculator. 6.28. Approximately 6.28 inches per second.
Yeah.
Am I reading my calculator? That does look kind of low, doesn't it? Yeah, that's fucking off. Yeah, 20 pi times, yeah, how did I, yeah. I should have looked at that and recognized that was wrong. Pi is bigger than 1 and I multiplied it by 20. 62.8 inches per second. I just looked down and looked at my notes and I saw that I had the 60, I'm like, what? And you guys were saying that loud right now. Any questions? That's 6.2, that's all I got for you. ETFO, have a good day, I'll see you guys on Thursday. What are we doing on Thursday? Thursday, we are talking about the graph of the sine and cosine function, this is good stuff. Thursday is gonna be good shit.